So this is section 1.5, which is all about linear inequalities. Just to we're going to start with a little bit of notation stuff. First off, a reminder of interval notation. Parentheses indicate that endpoints are not included in your interval. Square brackets indicate that the endpoints are included in the interval. And we always use parentheses for negative infinity and positive infinity. So we've got a couple ways we can express things. Here's a number line. It goes from A to B. You can see parentheses here, which indicates A is not included and B is not included. If we were to write this as an interval notation, it would be A comma B with both in parentheses. If we were to use set notation, we would say X such that A is less than X is less than B, which basically just says X is in between A and B. All right. Here's the same kind of thing, but with brackets. The only thing that changes on our interval notation is now it has brackets. For our set notation, all that changes is now we have equal tos instead of just less thans. Okay. You can also do a bracket on one side or the other. Okay. And when you do that, again, whichever one has the bracket gets an equal to in set notation. Put a bracket on it in interval notation. Okay. When we talk about an interval that starts at A and goes onward to infinity, we write it like this, A comma infinity, and if the A is in parentheses, we put it in parentheses here. As an inequality, in our set builder notation, we write X such that X is greater than A. And then again, you can do the same thing with a bracket to include the A. If you do an interval where you're less than a number, where you're going to the left, then you write it in interval notation as negative infinity to B, both of them excluded. In set notation, X is less than B. If you put brackets on it, again, that just means you have an equal to. And then if we go all the way to the left and all the way to the right, in interval notation, we write that as negative infinity to infinity. In set notation, you can either write it as X such that X is a real number, or you can use this special R symbol, which means all real numbers. Either of those works for set notation. So what we're going to do, just to kind of practice interval notation really quick, is we're just going to go over a few examples and talk about how to write them as inequalities and how to write them as intervals and all of that fun stuff. So example 1 here asks us to write each of these inequalities using interval notation. Our first one is 1 is less than or equal to X is less than or equal to 3. So that's saying that X is somewhere in between 1 and 3. So we would write 1 to 3. And then because of the equal to's, we would use brackets. And that would be our interval. 1 to 3, both of them included. Right, over here, negative 4 less than X less than 0. This is saying X is a number between negative 4 and 0. So our interval would be negative 4 to 0. Because these are just less thans, we would exclude both of those and we would use parentheses. And that would be our interval. This one, X is greater than 5. If it's greater than 5, that means it starts at 5 and then it goes greater, so it goes to infinity. With infinities, we always exclude, so we would always put parentheses there. For the 5, because this is just a greater than, we would use a parentheses. So that would be our interval. All right, and then D, we got X is less than or equal to 1. If it's less than 1, then that means it starts at negative infinity, and it goes all the way up until 1. Negative infinity is always excluded, so it's a parentheses. For the 1, because this has an equal to on it, we will include it, so we will put a bracket on it. And so that would be our interval. Right. Example 2 kind of goes the opposite way. It asks us to take an interval and express it as an inequality. So we have negative 1 to 4 with negative 1 excluded, 4 included. That would look like this. Negative 1 less than X less than or equal to 4. Because this says that X is between negative 1 and 4. We have to have an equal to on the 4 because of the bracket there on that 4. Okay. Letter B, we got 2.5 to 4, both of them in brackets. So that would be 2.5 is less than or equal to X is less than or equal to 4. Again, this says that X is between 2.5 and 4. We have our equal to's because they are both in brackets. All right, and then example 2c, we have an interval -4 to infinity. To express this one, we can't do compound like this with three things. All we do is we just say x is greater than -4. Because infinity is bigger than -4, so it's greater than. So we say x is greater than. And we're not going to use an equal to here because that -4 is in parentheses. So that's how we would write it as an inequality. Now, why are we talking about all this notation stuff? Well, in 1.5 today, we're going to be solving linear inequalities, which means we're going to get inequalities like this. And so it's convenient for us to be able to write the answer in interval notation, to be able to put it into the computer or type it or whatever. All right. So, as I said, we are looking at linear inequalities today. Linear inequalities are any inequalities that can be written like this. Ax plus b is less than 0, ax plus b is less than or equal to 0, ax plus b is greater than 0, or ax plus b is greater than or equal to 0. Now, much like equations, you solve them by isolating the variable, getting the x by itself. One thing to note, though, is that if you multiply or divide by a negative number, the inequality symbol is reversed. So a less than becomes a greater than, a less than or equal to becomes a greater than or equal to, a greater than becomes a less than, a greater than and equal to becomes a less than or equal to. So if you do a multiplication or a division by a negative number, you're going to have to reverse that inequality. All right, so let's look at a couple examples of this. Example 3 asks us to solve and graph the solution set on the number line. We have 3 minus 2x less than or equal to 11. First thing we'll do is subtract the 3 over. So I'll have negative 2x is less than or equal to 11 minus 3 is 8. And the next thing to do would be divide both sides by negative 2. Here the negative 2's would cancel out and we'd have an x. Over here, 8 divided by negative 2 would be negative 4. Because we divided by a negative, though, our inequality has to reverse, so now it looks like this. It's a greater than or equal to. Sorry, my little tablet acted up, but there we go. There's our equal to. So there's our answer. Now, if we wanted to write this in interval notation, then that means we would start at negative 4 in a bracket, and then we would go out to infinity, because x is greater than or equal to negative 4. Now they asked us to graph the solution on a number line. So here's my number line. I'm just going to put a couple of numbers on it. I'll put 5 numbers on it. So let's say this is negative 4 here in the middle. This would be negative 3, negative 2. This would be negative 5, negative 6. So I want to go greater than negative 4. So I'm going to put a bracket here on negative 4, and then I'm going to shade it to the right to make it go greater than. So there is my graph of that solution set. Okay. All right, another one. We have solve and graph the solution set on a number line. Negative 2x minus 4 is greater than x plus 5. I'm going to start by moving the x over. I'm going to subtract it over, so I'll have negative 3x minus 4 is greater than 5. Then I will add this 4 across, so I'll have negative 3x is greater than 5 plus 4 is 9. And then the last step is to divide both sides by negative 3. When I do that, the inequality will switch, so it'll become a less than. 9 divided by negative 3 is negative 3. So there's my answer. If I write that in interval notation, x is less than negative 3. It would be negative infinity all the way to negative 3, with negative 3 not included. Drawing this on a number line, and I'm going to put a couple of numbers on here. Here's negative 3, so this would be negative 2, negative 1, negative 4, negative 5. We want to go less than negative 3. I'm going to put a parentheses on -3, and then I'm going to color to the left to go less than. And so there's my graph of the solution set for this inequality. Okay. Example 5 asks us to solve and graph the solution set of x plus 3 over 4 greater than or equal to x minus 2 over 3 plus 1 over 4. Now because this involves fractions, what I'm going to do is I am going to take this whole thing and I'm going to multiply everything by 12. Now when I do that, this 4 could cancel with the 12 and we would still have a 3 left behind. This 3 could cancel with the 12 and we'd still have a 4 left behind. And then that 4 could cancel with it and leave a 3 behind. So we're multiplying 12 to all of these things and simplifying. So I have 3 times x plus 3, which is 3, excuse me. So that is 3x plus 9. And then I still have my greater than. 4 times x minus 2 gives us 4x minus 8. And then 3 times 1 gives us positive 3. So that's what we have once we get rid of the fractions. I will combine like terms on the left-hand side. So I have 3x plus 9 is greater than or equal to 4x, and then negative 8 and positive 3 makes a negative 5. I'll subtract the 4x over, so 3x minus 4x gives us negative x plus 9 greater than or equal to negative 5. I'll subtract the 9 over, so I have negative x is greater than or equal to, let's see, negative 5 minus 9 would be negative 14. And then I can divide both sides by negative 1. When I do a division by a negative, the inequality switches around, so it's now less than or equal to. Negative 14 divided by negative 1 is positive 14. So there's my answer. If I write it in interval notation, then x is less than or equal to 14. It means I go from negative infinity all the way until 14 with 14 included. For our number line, put a couple numbers on here. So here's 14. So this would be 15, 16. Over here we'd have 13 and 12. We want x to be less than or equal to 14. So I'm going to put a bracket on 14, and then I will shade over here to the left to make it less than. And so there is my result for that one. So that's kind of how those ones work. Now, sometimes when we do our math, when we solve these inequalities, we, instead of getting x is greater than something or x is less than something or whatever, what we instead get is a true statement or a false statement. What I mean by that is we might get a statement like 5 is greater than 3. Well, that is a true statement. 5 is greater than 3. In which case, what that tells us is that any number would work in the equation. X could be any number. So the solution set is all real numbers. If we get a false statement, on the other hand, something like 0 is greater than 2, then that tells us that the inequality has no solution. And so the solution set is the null set or the empty set. There is no solution. So let's look at some examples of that. And apparently my pen's going crazy. Alright, so example 6 asks to solve each of these inequalities. We have 2 times x plus 4 is greater than 2x plus 3. I'm going to distribute the 2 in, so I'll have 2x plus 8 greater than 2x plus 3. And then I'll take this 2x and I'll subtract it over. When I subtract it over, it'll cancel out, and so I'll just be left with x is greater than 3. That's a true statement, right? 8 is greater than 3. It's true. So that tells us that our solution set is all real numbers, which you can write in an interval as negative infinity to infinity. Okay. And B, we got x plus 7 is less than or equal to x minus 2. Here we would subtract the x over. When we subtract it over, it cancels, and so we end up with just 7 is less than or equal to negative 2. Is that a true statement? Is 7 less than or equal to negative 2? No, that is false. Okay. So this has no solution. Now again, we do have a symbol that means no solution. It's kind of a circle with a slash through it. That symbol means empty set or null set, which basically just means there is no solution set. Okay? And sometimes those things happen. They do. Let's look at a couple more examples. Example 7 asks us to solve and graph a solution set on a number line. Negative 5 less than 3x minus 2 less than 1. This is our first real compound inequality, but they kind of work the same way. It's just whatever you do to the middle, you have to do to the left side and the right side. So here, I want to get rid of this minus 2, so I need to add 2. If I add 2 to the middle, I have to add 2 on the left and add 2 on the right. So negative 5 plus 2 gives me negative 3. Less than 3x, and then 1 plus 2 gives me 3. And then I want to get rid of the 3, so I would divide, but if I divide the middle by 3, I have to divide the left by 3 and the right by 3. So I end up with negative 1 is less than x is less than 1. If we write that in interval notation, that would be negative 1, comma 1. With both of them excluded. Graphing it on a number line. Okay. Let's say this is negative 3, negative 2, negative 1, 0, 1, 2, 3. I want to go from negative 1 to 1. And I want to use parentheses, so I'll have a parentheses here at negative 1. I'll have a parentheses here at positive 1. And then I would just shade this area in between so that I have that interval in between negative 1 and positive 1. So that would be my solution. All right. Example 8 asks us to solve and graph the solution set. We have negative 1 less than or equal to 3 minus 5x over 2. Less than or equal to 9. Another compound one. First thing I'd want to do is get rid of the divide by 2. To get rid of divide by 2, I need to multiply by 2. If I do that in the middle, though, I have to do it on the left and on the right. So negative 1 times 2 is negative 2. Less than or equal to 3 minus 5x. Less than or equal to 9 times 2, which is 18. Then I'd like to get rid of the 3. To do that, I would need to subtract. So I'm going to subtract 3 everywhere. Negative 2 minus 3 gives me negative 5. Less than or equal to negative 5x. Less than or equal to 18 minus 3 is 15. And then the last thing to do to get the x by itself is to divide everything by negative 5. Now, when I divide by a negative, though, remember that the inequalities are going to switch. So these are going to become greater than or equal to. We'll have x in the middle. And then over here, negative 5 divided by negative 5 is positive 1. Over here, 15 divided by negative 5 is negative 3. So x needs to be between negative 3 and positive 1. If we write that in interval notation, it would be negative 3 to positive 1 with both of them in brackets because of the equal to's. When we graph this, so this is negative 3, negative 2, negative 1, 0, 1, 2, and 3. To do negative 3 to 1, I'm going to put a bracket here on negative 3. I'll put a bracket here on 1. And then we color in this area in between them to show that that's our interval. That's where our solution set is. Okay. So that's how that one works. We have a couple more examples. First thing, we have what's called the reciprocal property for inequalities. What it says is that if a is a number that's bigger than 0, then 1 over a will also be bigger than 0. So what that means is if a is a positive number, then the fraction 1 over a will also be a positive number. Its reciprocal will be a positive number. Similarly, if you have 1 over a is bigger than 0, then a will also be bigger than 0. So if the reciprocal is positive, the original number has to be positive. The same thing works as well with negative numbers. If a is a negative number, then the reciprocal will be a negative number. If the reciprocal is a negative number, then the original number would be a negative number. And that does come in handy a little bit when solving inequalities, things like this. This one asks us to solve and graph 4x minus 1 to the negative 1 power is greater than 0. That negative 1 power there means that this goes on the bottom, so this is really 1 over 4x minus 1 greater than 0. That's what that negative exponent means. It means this goes on the bottom of the fraction. Well, according to our property, this is a reciprocal. It's 1 over something, so it's a reciprocal. Well, if this is true, if this reciprocal is greater than 0, then we also know that that needs to be greater than 0, 4x minus 1. And then we can solve that equation. We'll add the 1 over. We say 4x is greater than 1. Divide both sides by 4. So we get x is greater than 1/4. Writing that in interval notation, if we want x greater than 1/4, we would say 1/4 to infinity, with the 1/4 excluded. Graphing it on a number line. So this is negative 2, negative 1, 0, 1, 2. 1/4 is going to be here, a quarter of the way between 0 and 1. So about a quarter of the way through, I'm going to put a parentheses, and then I'm going to color in towards infinity to be greater than that number. And so that's my solution. Again, this relies on us understanding that if a reciprocal is greater than 0, then the flip of it, the original, will be greater than 0. Okay. Alright. Example 10. It's kind of a thinking example, which is actually one of my favorite ones. It says, if negative 1 is less than x is less than 4, find a and b, so figure out what these numbers are, so that a is less than 2x plus 1 is less than b. So I'm going to start out with this inequality that they gave me. Negative 1 is less than x is less than 4. Okay. And what I want to try and do is I want to try and turn the middle of this, which is just x right now, into the middle of this, which is 2x plus 1. The first thing I need to do is I need to get a 2 in front of that x, which means I need to multiply everything by 2. Negative 1 times 2 is negative 2. X times 2 is 2x. And 4 times 2 is 8. Now I'm a little bit closer. Now the next thing I need to do is I need to add a plus 1. So I need a plus 1 on all of these. Negative 2 plus 1 gives me negative 1. 2x plus 1 gives me 2x plus 1. And 8 plus 1 gives me 9. So now I have what's in the middle of here. I have the 2x plus 1. So that tells me whatever's on the left is a and whatever's on the right is b. So I know a has to equal negative 1 and b has to equal 9. So it's kind of a little thinking problem. Going from this to this, what do you need to do? Multiply by 2, add 1. So, a little bit of thinking. Alright. The last things we're going to look at are some application problems for this. So, our first one says, Acme Car Rental Agency charges $4 a day plus 15 cents per mile, whereas Interstate Rental Company, or agency, charges $20 a day plus 5 cents per mile. And so it asks us how many more miles must be driven to make the daily cost of an Acme rental a better deal than an interstate rental. Well, if Acme is a better deal than an interstate rental, that means that Acme is less than interstate. If it really is a better deal. Okay. So Acme needs to be less than interstate to make it a better deal. So let's see what we got. Acme charges $4 a day plus 15 cents per mile. So 0.15, and I'm using M for miles. Interstate charges $20 a day, and they charge 0.05, or 5 cents per mile. There we go. There's our inequality. Now all we got to do is solve it. First thing I'd do is subtract the 0.05. So I'd have 4 plus 0.10 m is less than 20. Then I would subtract the 4. So I'd say 0.10 m is less than 20 minus 4 is 16. And then the last thing to do would be divide by that 0.10. So here in my calculator, I'm going to do 16 divided by the 0.1, and I get 160. So my expression says that m has to be less than 160. So how many miles must be driven to make Acme the better deal? Well, if you read this expression, it needs to be less than 160 miles. And I will apologize about my handwriting. I'm writing this with the mouse right now because the tablet is not cooperating. But there's our answer. If you drive less than 160 miles, Acme is the better deal. When you hit 160, they're actually equal. And if you go bigger than 160, then interstate becomes the better deal. Okay, so there's our answer for that one. All right, our last one. Our last one says that in electricity, Ohm's law states that E equals IR, where E is the voltage in volts, I is the current in amperes, and R is the resistance in ohms. They tell us an air conditioning unit is rated at a resistance of 10 ohms. So we already know R is equal to 10. They tell us the voltage varies from 110 to 120 volts exclusive. So what corresponding range of current will the air conditioner draw? Okay, well, voltage is E, so they're telling us that our E varies from 110 to 120 inclusive, which means that we do include those endpoints. So we have this expression, 110 has to be less than or equal to E, has to be less than or equal to 120. So E is between 110 and 120. Now what I'm going to do is I'm going to replace E with this equation that we know. So instead of E, I'm going to write IR. Because E is the same thing as IR, so I can just kind of replace it. So 110 has to be less than or equal to IR, which is less than 120. And here's the thing, though. We know what R is. R is 10, so we can plug that in there, and we can say 110 has to be less than or equal to 10I, which has to be less than or equal to 120. And then all we got to do is solve for I. So to solve for I, we would divide everything by 10. And so we get 11 is less than or equal to I is less than or equal to 12. Now what is this I? The I is the current measured in amperes. So we have to say our answer is between 11 and 12 amps. Amps is shorthand for amperes. And then we do need to say inclusive, because we have to say that we're including those endpoints. So anywhere between 11 and 12, with 11 and 12 included, is sufficient, matches up. That's how much current the air conditioner is going to draw, how much electricity it's going to pull. Okay? So there is that problem. So that is it for 1.5. Make sure you work on your assignments. Again, if you ever have any questions, feel free to either use the Ask My Teacher function in my math lab, or feel free to send me an email, and I'll try and get back to you.